Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Muhammad Azri Hazim and I will be the first presenter for Group 12. So I will be presenting intro first, which is numerical method. It is a mathematical technique for solving complex problems in science and engineering. When direct solutions are not feasible, it will involve creating, analyzing, implementing an algorithm like Euler and Newton method. So we'll be focusing on chapter 7, which is eigenvalues and eigenvectors, which is a key concept in linear algebra. This is a system natural frequency, while eigenvectors maintain direction under linear transformation. They have application to stability analysis, vibration and facial recognition, etc. So it came in two methods like matrix diagonalization, which transforming the square matrix, and Langzos algorithm, which calculating eigenvalues and eigenvectors of large symmetric sparse matrices, optimizing compensation. So next slide is we'll be presenting about the real world problem, which we conclude to have include 4 real world problem. I will be presenting 2, which is the first will be machine learning. The principle of component analysis, also known as PCA, is used to reduce the dimension of multivariate dataset while retaining most of the information. The process visualizing fitting an ellipsoid of data. So in simpler form, with less significant axes with minimal variance can be omitted, while the remaining axes align direction maximum variation in the original observation. So in math terms, the PCA is an orthogonal linear transformation will be converted into a metric diagonalizable form. It can reduce the number of correlation variables into a smaller set of uncorrelated variables like principal components. For example, the face recognition eigenfaces are used, which derive a covariance metric of face image underlying that represent the pattern. So the similar techniques are also shown, while the down here will be the formula used in incorporating the concept of eigenfaces. Okay, next slide. The next real world problem will be focusing on angular momentum and angular velocity. The principal axis is the axis where angular velocity vector and angular momentum vector align in the same direction. When the body has symmetric relative to the principal axis, the product of inertia becomes 0. Okay, in 3-dimensional space, it's possible to identify 3 mutual perpendicular axes where the product of inertia becomes 0, resulting in diagonal form of inertia matrix. The equation I minus by I omega equals 0 relate to the moment of inertia of the body, representing this by the scalar L, the angular velocity vector W, the each corresponding principal axis L1, L2 and L3 will be insert into this formula, and the character vector represent the moment of inertia will be along the principal axis. In case of applying pressure to solid material, the result of the deformation can be divided into principal directions. The eigenvectors can represent this principal direction, and the eigenvalue can indicate the percentage of deformation along of each principal direction. That is all from me. Thank you.
Assalamualaikum and hello everyone. My name is Mohd Azwan bin Rosli, metric number DD200021. Today I will present about real world problem for bridge construction, vibration. Vibration are widely used in mechanical engineering, civil engineering, communication engineering and automobile engineering. Axial motion of bar, beam vibration, buckling of a beam bar, stereo system of car, aerodynamic, and etc. Continuous cycling motion of a equilibrium point is called vibration. Engineers try to avoid it due to damaging effect caused by cyclic force created by cyclic motion, unwanted sound, and wasting of energy. The collapse of the famous Tacoma narrow suspension bridge was a result of unforeseen vibration. The mass spring damper model, one of basic concept of vibration, use eigenvalue to calculate frequency and mode shape for vibration. For example, the equation of motion of the 2 degree of freedom 2DOF system can be expressed as mx2 prime plus cx prime plus kx equal to f, where m, c, and k are symmetric metric represent of the mass, damping, and stiffness properties of the system, respectively. Where there is free vibration, no damping, and no applied force, the equation simplified to mx prime plus kx equal to 0. By assuming an exponential solution of the form x exponent power of I omega t, where x represents the mode shape and the omega represents the angular frequency, the equation can be further simplified to k minus omega power of 2 mx equal to 0. This equation is known as the eigenvalue problem because it seeks the eigenvalue lambda and eigenvector x of the system. By pre-multiplying the equation by m power of -1 and defining k equal to a and omega power of 2 equal to lambda, it can be written as a minus lambda L power of x equal to 0. The eigenvalue lambda obtained from the equation provide the frequency of the system's oscillation, and corresponding eigenvector s represent the pattern of motion or shape mode of the system. Each eigenvalue is and its corresponding eigenvector define a specific free vibration mode of the structure. The JTH eigenvalue refer to the JTH frequency, where the frequency is equal to omega over 2 pi. Understanding the eigenvalue and eigenvector of a system allow engineers to analyze its vibration behavior, identify resonant frequency, and design appropriate measure to avoid detrimental vibration. Next, Google PageRank. The purpose of the PageRank there are approximately 6 pages on the web, and the author of page 1 believes that, for instance, page 2, 4, and 6 have excellent content and link. Page 2 author, however, only connect to page 1 and 4 since the things they are excellent. We may iteratively assign a rank to each web page based on the rank of the page that lead to it, whether we are talking about popularity or authority. It indicates that we think the page I is significant and pertinent to our issue if we construct web page I and link to it. It is assumed that page I is significant if there are numerous pages that connect to it. On the other hand, if I just had one black link but it comes from the rebuttable sites such as www.google.com or www.cnn.com or www.kernel.edu, we can argue that the authority of the site have been transferred to I. In other hand, the authority of the site says I is significant. Method of assessment. In reality, there are many problems that are related to eigenvalue and eigenvector in terms of solving them. As in general, every system has its own natural frequency that can be obtained from eigenvalue, and the mode shape can be obtained from the eigenvector. Hence, there are a few methods to use in solving a problem related to this topic, which are by using the characteristic equation and software coding for validation. So first, from Hooke's law, f equal to kx, we got f1 equal to negative k1 x1 plus k2 in bracket x2 minus x1, and f2 equal to negative kx in bracket x2 minus x1. So from Newton's second law, f equal to ma. So first, f1 equal to m1 x1 double prime, and second is f2 equal to m2 x2 double prime. So by combining these two equations, we got m1 x1 2 double prime plus in bracket k1 plus k2 x1 minus k2 x2 equal to 0. That is for equation 1, and m2 x2 double prime plus x2 in bracket x2 minus x1 equal to 0 is for the second equation. So in vibration system, velocity and acceleration are expressed as x1 equal to v1 sin omega t. So we differentiate it to x prime 1 equal to w v1 cos omega t, and we differentiate it one more time equal to x1 double prime equal to negative omega square v1 sin the omega t. So that's for equation 3, while x2 equal to v2 sin omega t, x prime 2 equal to w v2 cos omega t, then x2 double prime equal to negative w square v2 sin omega t. So that's for equation 4. So by substituting equation 3 into 1 and equation 4 into 1, we got negative m1 w square v1 sin omega t plus in bracket k1 plus k2 v1 sin omega t minus k2 v2 sin omega t equal to 0. The second equation is negative m2 w square v2 sin omega t plus k2 in bracket v2 sin omega t minus v1 sin omega t equal to 0. So by simplifying the equation, negative m1 w square v1 plus in bracket k1 plus k2 v1 minus k2 v2 equal to 0, we divide it by m1 and we got negative m2 m square v1 plus in bracket k1 plus k2 over m1 v1 minus in bracket k2 over m1 v2 equal to 0. And second one is negative m2 w square v2 plus k2 v2 minus k2 v1, and we divide it by m2 and we got negative w2 v2 minus in bracket k2 over m2 v square v2 minus in bracket k2 over m2 v1 equal to 0. So the figure shows the metric for the equation, and we let lambda equal to w2 since the v is not equal to 0. So this is for the software coding for validation. There are a few software that can be used to validate the calculation of the project, which are MATLAB, FreeMat, and so on. However, in this group, we decide to use either MATLAB or FreeMat. So the figure shows our result that we are used for validation from the software. That's all from me. Thank you.
Assalamualaikum. My name is Ahmad Zulfadzli Yusri bin Ghazali. My matrix number is DD200009. Now, I would like to present the result and discussion. First, the result by manual calculation by using table. First, we have to do the diagram and the equation of motion from the diagram. Then from the equation, we divide by m, and then we put in the matrix form. Then we put the assume value, and then we assume harmonic motion, and then we rearrange the matrix form into the I minus lambda I equal to 0, and then we apply self rule to form the characteristic equation. And from the characteristic equation, we have the eigenvalues. So from the eigenvalues, we find the natural frequency, and then we use the lambda to find the first, second, and third eigenvectors. That's it.
Assalamualaikum. So we go to the result by the FreeMat. We can see the value of 8 vectors and the value of the 8 values. We can compare it with the manual calculation. So we go to the discussion. The real problem that we choose as our case study is bridge damping vibration 2 degrees of a freedom, which is the mesh attached both end wall. From the situation, we draw the free body diagram for spring mass and generate the equation of motion to solve our case study problem. The value of springs, constant and mass are assumed, which is K1, K2 and K3 is 9 Nm, 5 Nm and 6 Nm respectively. For M1, M2 and M3, the value is 4 kg, 2 kg and 3 kg respectively. Before we determine the eigenvalues, we apply the Serre's rules to obtain the characteristic equation. From that, we can straight away determine the eigenvalues. Based on the calculation, the eigenvalue are, the firstly is 1.6223, the second one is 3.8154, the third one is 7.8953 respectively. So we can see the value of a corresponding eigenvector, which is a V1, V2 and V3. The natural frequency value are, the firstly is 1.2737, the second one is 1.9533, and third one is 2.8099 respectively. Value are validated by using free maths. All the eigenvalue for free maths is the same as manual calculation. Hence, the manual calculation is more accurate. That's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Megat Iskandar and my metric number is DD 2023. So today I will talk or discuss about the conclusion and recommendation. So for the conclusion is our objective for this project is to find a mechanical system agent values and corresponding agent vectors using the appropriate numerical method. So the result has been obtained from the standard matrix iteration method, and the whole methodology for prescribing the relationships between the bridge construction and the vibration is verified by using the agent values and the corresponding agent vectors, and also using the free math software. And then these agent values and the corresponding agent vector method is useful to obtain, and the steps of the method are easy to be done. And then furthermore, this method helps engineer to obtain the value of vibration of a bridge construction easily as the wall is developing and advanced, and a faster method is needed to calculate the value. So for the recommendation, the value obtained is then validated using free math. Here we assume the manual calculation was accurate, since all the agent values for free math are the same as the manual calculation. Agent vectors and agent values are key concepts used in feature extraction techniques such as principal component analysis, which is an algorithm used to reduce dimensionality while training a machine's learning model. And then the study of agent values and the corresponding agent vectors can help in the construction industries that need stabilities and analysis, vibration analysis, atomic orbitals, facial recognition, and metric diagonalization. Sorry. So that's all for me. Thank you.